Hi my friends, today we model this part. You see that it has interesting features. This is the drawing. We start by creating this revolved part with some dimensions here. New standard millimeters IPT, new sketch, XY plane, and we draw a vertical line to be an axis. Dimension is 28 plus 7. This is a center line. Then we draw other lines. Vertical, right, left, down, again here we want to be at this level with another vertical, then somewhere here we draw an arc with a radius of 10. All dimensions are in the drawing, of course. This center is on the same vertical with the center point, and here is a distance of 6. This is 33. This is 35. Then 27. And again 33. This is 7. This is 2 millimeters, and this is 4 millimeters. The last dimension is, I don't know what is the missing dimension, so I apply auto dimension to see. Oh, 35. I know this point must be included in this line. Good. Revolve, and we have the first volume. The part has a chamfer, and now is the moment to apply that chamfer 0.5 at 45. Next is this hexagonal feature with dimension 43 minus these two dimensions and this dimension. Okay, we select this face, we select polygon with 6 sides, this center and this placement. Vertical is this, and 22 is this dimension. Okay, we apply extrusion by using that expression, 43 minus 27 minus 28, not 27, minus 7. Okay. Then we use this plane to apply a line, but let me project these two lines. These are not important. I eliminate one of them and I draw a line here. This distance is 22 divided by 2, and this angle is 30 degrees. Finish sketch, revolve, the axis is Y with cut. Okay, you see 22 is for placing here tangent curves. These are that dimensions, 30 degrees and 22. And now we take a look at this hole, diameter of 4, placed at 4 millimeters up. We use this face to create a new sketch with a point only, and this point must be placed on the same vertical with the center point. Then a dimension of 4 millimeters. Finish sketch, hole 4 millimeters through the part. Okay, another hole is this one, diameter 14, depth 11. We create a hole by selecting this face and this center with end is that hole. 11 is the depth and 14 is the diameter. Okay, the part has these three features at 120 degrees with dimensions here 120 degrees, 3 of 3 millimeters. Let's create this the sketch for this construction. We draw a line by selecting this diameter, a line from the circle down to somewhere here, and then here. This distance is 3 divided by 2. And this is also 3 divided by 2. I take the dimension from here. The angle is 120. Finish sketch, extrude. Let's see what is the depth. 28 is the depth. We select this, the other direction, and 28. Okay. Then we apply the circular pattern of the last feature about this axis, not 6 but 3 times. Yes. The next feature is this spherical feature with dimensions here. Radius 10 spherical at a distance of 13. We use this plane, XY, F7, and we draw a circle with a radius of 10 with the center on the same vertical with a center point and at a distance of 13. From up. This is the distance. Then we draw 2 lines from the center or to the center and outside. We trim this arc and we apply center line for this vertical line. Now we have a fully constrained sketch and apply revolve 360 degrees. Okay, this is the result. Now we have to create this notches, 64 notches equidistant, and we want them to be connected. I mean that this line and this line to be exactly coincident to the circle. This means that we have to apply something interesting and new. We have to open this parameters tool or to go to manage and select parameters. If you don't have it here, you have it and this line. We have here all dimensions. Yes, and we create a new value with the name Z for notches, tab not millimeters but UL, unitless, number of 64. We want here to have a equation by using this parameter Z with a value of 64. Why do we need this? Because this angle is 60 and we'll use this arc, the length of this arc. When you see parentheses, it means that this is a resulting value, as well as this one. We start by creating this small area, and we'll use that Z with the value of 94. Take a look here. We use this plane and we project the circle. We draw two lines with this point aligned with this and equal the two lines with an angle of 60. This is 60. Now, since we want to have 64 of these notches, we draw an arc here from this point to this point and coincident with a circle, or making equal this arc with this circle. Why? Because we apply now a dimension of this arc, not the circle. I wait here to select the curve, and this curve is dimensioned with the arc length. The arc length is this diameter of 35, and I multiply it with the well-known constant pi to obtain the circumference of the circle. You see, if you write here pi with minor I, it is not good. You have to place pi. This is p with a lot of decimals, divided by z. Again, with capital Z letter. Yes? Okay. This is the first step. Now we use the XY plane for a new sketch. We can project this point to create a circle. This circle containing that projected point. This circle has this distance to the center point of 32, and the other distance to that point of 10. I apply measure with the key M from Monaco, and I measure this. This is a diameter and the radius is this, with the value from the drawing. We don't need it at all, because all we have to do now is to apply sweep of this area about this full circle with cut, not join, but cut. Okay, you see the notch. We apply circular pattern for this last feature about this axis and number of Z times. Yes, if you write here Z minor, you don't have a good solution. Capital Z is the solution. Okay. Now we have this point common to both faces, yes? Now I see that this is not the conical end of the hole. Let's see what is the problem. Double click, F7. Oh yes, you see, I project this line, I apply split here and construction. Nothing was changed concerning of the spherical feature, but when I finish, I accept and I double click on the revolution because I have to use the new area instead of that other one. Good. Now let's see what is the volume. Properties, physical, update, copy, close, drawing, double click, and the new value is just the same. Cancel. I keep this because it is the same. Then the material is still carbon. The general aspect is special gunmetal antique. Then I select this face, this internal, this, and each of these three to be titanium polished. Then view with no edges and the other light, default light. Now you see there is no difference between them. Oh, it is. This is also as titanium polished. Now once again we see how it looks. That's all for today. Thanks for watching. Bye bye.